Let's jump right in, guys. Today, we're setting our sights on a truly mind-bending scientific discovery, one that completely bridges the gap between ancient paleontology and the living, breathing animal behaviors we see right now. We usually think of fossils as, just static old bones, right? Rarely do they capture a prehistoric creature right in the middle of a complex social behavior. So, let's unpack this analysis of an ancient snake huddle, literally frozen in stone.
Okay, let's dive into this by just taking a second to wrap our heads around this massive number, 34 million. We're jumping back roughly 34 to 38 million years into Earth's past. I mean, that is an immense timescale. Mammals were evolving like crazy, the climate was shifting, and the landscape of North America, it looked vastly different than it does today. Trying to picture the exact day-to-day lives of creatures from this era is, well, usually a bit of a guessing game. But every so often, the Earth hands us a perfect, frozen snapshot of the past that changes everything we thought we knew. Now, to understand the past, we really have to look at the present. If you've ever watched a nature documentary about modern snakes, like garter snakes, for example, you might have seen a phenomenon that is both absolutely incredible and, let's be honest, kind of creepy. As winter rolls in, thousands of these snakes travel to specific dens and gather together, intertwining into these massive writhing balls. But why do they do this? It's not just some random social gathering. It's a vital, calculated instinct to actually survive the freezing winter.
Chapter 1, Le mystère de l'hibernation, the mystery of hibernation.
So we know modern snakes do this, but how deep into the evolutionary tree does this behavior actually go? Let's break down the biology really quick. We call this hibernation huddling, and it's a highly effective survival tactic. By gathering in these massive intertwined groups, these cold-blooded reptiles can share whatever minimal heat they have. They reduce the amount of their body surface exposed to the freezing air and collectively endure extreme temperature drops that would, without a doubt, kill a single snake out on its own. It's a super sophisticated behavioral adaptation, but for the longest time, we had absolutely no idea when snakes first figured this out. Was it a recent evolutionary trick or something much, much older?
Chapter 2, Une découverte dans le Wyoming, a discovery in Wyoming.
To find out when snakes first figured this out, we have to look at a definitive discovery. The scene is the White River Formation in Wyoming. This geological formation is absolutely famous among paleontologists because it acts as a phenomenal window into the ancient world of the late Eocene and early Oligocene epochs. Right here, researchers uncovered 4 incredibly well-preserved snake specimens. And when I say well-preserved, I mean they found intact skulls, delicate jawbones, perfectly articulated vertebrae, the whole shebang. But honestly, it wasn't just what they found, it was how they found them that really made jaws drop. Now, what's really interesting about this slide is our star character, these intertwined fossilized skeletons. This is a newly discovered genus and species officially named Hibernophis breithaupti. Notice how these super delicate skeletons aren't just scattered randomly, they are physically grouped together, curled up and touching, preserved in the exact same huddling posture we see in modern snakes trying to survive the cold. It is quite literally a 34-million-year-old hug, completely frozen in time.
Chapitre 3. La technologie révèle l'invisible, revealing the invisible.
To truly understand this fossil, it took an international collaboration of paleontologists from Canada, Australia, and Brazil, using what is essentially a Trojan horse of modern scientific technology. When researchers first found the main rock block, they could clearly see multiple intertwined specimens right on the surface. But instead of chipping away at the fragile rock and risking destroying these priceless 38-million-year-old bones, they used scanography. Basically, high-powered CT scans. This non-destructive tech peered straight through the solid stone and revealed something totally amazing. A hidden third snake completely trapped inside the rock, perfectly grouped with the others. This proved beyond a shadow of a doubt that this was a deliberate, multi-snake huddle, and definitely not just 2 snakes that happened to die next to each other.
Chapitre 4, Anatomie d'un serpent ancien, Ancient Snake Anatomy. Now that we know how they behaved, we really need to know exactly what they were. Based on those stunningly preserved skulls and jaws, researchers determined Hibernophis breithaupti was a relatively small snake and likely a burrowing species that lived its life underground. But anatomically, it's a fascinating puzzle piece. It shares physical traits with early booids, the ancestors of modern boas, and is linked to the Charonidae family, which includes modern rubber boas. And this brilliantly illustrates a vital, early transitional step in the evolution of boa-like snakes, placing it right near a major evolutionary split.
Chapitre 5, Repenser l'évolution des serpents. Rethinking snake evolution.
This little burrowing snake forces us to totally rethink the broader picture here. If we contrast the ancient ecosystem with today's world, the difference is basically night and day. In ancient North America, some 34 million years ago, the ecosystem was entirely dominated by constrictors, much like our newly discovered friend. It was literally a world ruled by ancient boas. But today, the modern ecosystem in North America is dominated by entirely different lineages of modern snakes, like colubrids. Finding Hibernophis breithaupti proves that the evolution of snakes was much more gradual and heavily branching than we previously thought. And it really cements the fact that the North American continent had a massive, outsized influence on the early evolution of boa-type snakes, long before those other modern lineages took over.
So the crucial point is that this discovery is a huge double victory for science. It's a physical missing link, yes, but more importantly, it is hard behavioral proof. Paleontologist Michael Caldwell from the University of Alberta beautifully summarized it. He said, "Seeing traces of this gathering behavior 34 million years ago is impressive. It completely redefines our timeline. The complex social instinct to seek out your own kind, huddle together, and wait out the freezing winter, it isn't some new trick. It's a deeply ingrained survival mechanism that has been hardwired into the brains of snakes for at least 34 million years."
It really makes you look at the natural world differently, doesn't it? When we see a modern animal acting on instinct today, we are witnessing the echo of a behavior that might be tens of millions of years old. And it leaves us with an incredibly thrilling question to ponder. What other modern animal instincts, from migration patterns to complex social bonds, are currently locked away in ancient rocks, just waiting for a paleontologist's CT scanner to bring them to light? Thanks so much for joining me for this analysis. Keep that curiosity alive, and I'll catch you next time as we unpack another fascinating piece of our world.